The amount of Coca-Cola in a bottle can be modeled as a normal distribution with a mean of 500 ml and a standard deviation of 3 ml. The bottles with the top 25% of volume will be made into premium bottles. What is the minimum amount of Coca-Cola in a bottle that will be made a premium bottle? The first things first is to get to the inverse normal distribution part in your calculator so you can actually start solving the problem. So the first thing to do is on your main menu, you want to go to Stat, click that. Go to Distributions F5, click that. Go to Normal F1, click that. Go to Inverse Normal F3, click that. Now you're left with this screen. Now you got to think about, what is the problem actually saying? What am I looking at here? So the bottles with the top 25% of volume. So you're looking at the data from the right side because the top 25% will be on the right side of the number. And it's 25%, so it must be the 0.25 of the area. So we'll pull up the graph and it should look something like this. Right, so everything to the right, which is the red region, that's what we're trying to find. That's good. Now we need to put in some basic numbers into the calculator, which were given from the start of the question right here. So the mean of 500 and standard deviation of 3 ml. So we're given this information here, and we see that the mean is 500 ml, which is mu. So we go in and put in 500 here for the mu, and then SD, which is sigma, is 3 ml. So we put in 3 in here. That's good. Now we see the tail is to the right. Right, because it's the right side of the data that we're looking at. So we need to make sure that the tail says right here, which you do by pressing F2 in the tail area. And the area is 0.25 because we're looking at the top 25% of volume. So it'd be 0.25. All the numbers are in place now. Go down, click execute. The number is 502.023469, and that's your basic answer there. And in context, it would be something like the minimum amount of Coca-Cola in a bottle that will be made a premium bottle is 502.023469 ml.